So last time we learned about reflecting, right? So we had a line that we reflected across. We have another fancy word today. This is on the Inquiry Lab on page 473. We're talking about rotational symmetry. So that's where you take an object, and if you rotate it, where will it go back to the exact same thing? So let me just show you some common things that I have. Like if I were to have this, pretty much no matter where I turn it, it's always going to be the exact same shape, right? It'll always look the same. It'll be in the same position. I mean, maybe you could talk about it. Do you see like those little edges on it? Maybe you could say it has to move exactly those edges, right? But this has a lot of rotational symmetry. But if I were to take something instead, like this rectangle, it's the same here, or it's the same if I turn it all the way upside down. Would you guys agree with that? Yep. So if it's in the this has rotational symmetry. It has it if it can be rotated or turned less than 360 degrees about its center. So here's the center, and we would rotate it so that the figure looks exactly as it did in the original position. So like for example, here's this thing. Does this thing have rotational symmetry?
No.
No, because I would have to turn it all the way around before it looked like the exact same thing, right? Or if I had this thing, does this have rotational symmetry, how it's cut and everything?
No, that does not.
No, because see how it kind of is like a little bit longer over here, and there's also the lines. So even if I were to turn it upside down, then the little weird long part is over here and the red line's on the bottom. So it does not have rotational symmetry. Let's see, what else do we have? Here's another example of something that would have rotational symmetry. So this one, if I were to take this, how many different positions can I be in for it to be the exact same thing?
4.
So I can turn it like this. So there's 1, 2, 3, 4, right? So basically I could take that 360 and split it into how many degrees? I mean, how many pieces?
4.
Yeah, so then what is 360 divided by 4? So I could rotate it 90 degrees, like, do you see that? And it would be the same thing. Rotate it 90 degrees, same thing, 90 degrees, same thing. Is that going to be the same thing with this?
No.
No. Does this have rotational symmetry?
Yes.
Because if I turned it all the way around, it looks the exact same thing, so yes. So you'd only turn it, how many degrees is that to go from here to there? 180, nice. Okay, so how many would this have?
4.
It would have 4, so how many degrees could you do it?
90.
90, nice, good. So the question is, does it have rotational symmetry? And the answer would be yes. So we can put in here, yes, yes, and it could turn it, you could say it fits into 4 turns, I guess. I don't know. 4 turns. I don't know how else to say that. Okay. Got it? Yes? No?
Yep.
Good. All right, so then let's just look at these other things. Does this logo here have rotational symmetry?
Yes.
Yes. In fact, how many degrees would you have to turn it?
180.
So you would just put yes, and then we can put 180 degrees. Okay. Does this have rotational symmetry? No. Does this?
Yes.
Ooh, how many degrees is that?
30.
Because there are 6, right? You guys saw that there were 6, and so we could do 360 divided by 6, which is what?
60.
60. Nice work, Bryson. Okay. Does the Olympic thing have rotational symmetry? No. Okay. All right. And so then that's the angle of rotation. So the angle of rotation is like how many times it is divided by 360. We already did that. And we already figured it out because we're pretty much amazing, right? Okay, so now we're officially doing the lesson.